Welcome to the 9th in our Aurea software evaluation video series. In this lesson, we will learn how to parameterize the Airwheel feature. First, we will have a short overview of the Airwheel. Then, we will go through different parameterization steps. 3 parameters are available: minimum momentum, smoothness, and minimum arc. The Airwheel is part of the Calibri suite's circular gestures. It provides a counter which can be either increased or decreased. The counter increases with clockwise circles and decreases with counterclockwise circles. The direction of the Airwheel can be reversed as the gesture is being performed, allowing you to smoothly switch between increasing and decreasing the counter. Each time an Airwheel starts, its counter value is reset to 0. Aurea uses a global application counter which accumulates each Airwheel counter change. It also uses a defined application counter resolution corresponding to 32 Airwheel counts. With the default settings, 32 Airwheel counts correspond to approximately 1 full circle. The Airwheel is expected to work out of the box for most designs with default settings. However, let us go through the available parameters and see their impact on the feature. We start with minimum momentum. This parameter changes the amount of movement required to update the Airwheel counter. High values improve robustness against small changes like jitter, but may require the finger to move closer to the sensor board. With smaller values, Airwheel is faster to react, but also more affected by jitter. Let's decrease the slider to 10, for example. If we start performing an Airwheel by doing 1 full circle and then start constantly moving our finger back and forwards without doing circular movements, we can see that the Airwheel is sensitive to these small changes. The Airwheel keeps responding to the hand movement. This finger movement can have the same effect we get from noise. Let's increase the slider to 150 and repeat this sequence. Again, we start performing an Airwheel by doing 1 full circle, and then constantly move our hand back and forwards. We can now see that the Airwheel is not responding to these small changes. The second parameter is smoothness, which influences the speed and smoothness of the Airwheel counter. For low values, the counter changes slowly. For high values, the counter changes quickly. Smaller arcs correspond to higher counts. In our example, the smoothness parameter is adjusted in a way that 1 hand circle movement results in 1 entire application counter rotation. If the smoothness is decreased, the Airwheel counter is slower. Several hand circle movements are necessary to get a full application counter rotation. The last parameter is the minimum arc, which adjusts how much rotation is required to trigger the Airwheel. A higher value means that a bigger arc has to be performed before the Airwheel counter starts. We see here that we just have to rotate our hand by 90 degrees to start the Airwheel. Let's increase this value and see what the impact will be on the Airwheel. We move the slider to 40, for example, and as we see, we need to do several circles before the Airwheel starts counting. What is important to keep in mind is that the minimum arc setting affects both discrete HMM circle gestures, events, and the Airwheel. A circle event is only recognized if this same minimum arc is performed. This tutorial described Airwheel parameterization.